All of you, I will switch off my video and start presenting now. I found some useful animations. I thought we can start with some animations. Probably make you feel better. எடுத்தோன்னே problems போகாம கொஞ்சம் animations பார்க்கலாம். So if you go to this ophysics.com, I found a lot of very useful simulations. Of course, I have been showing you for other topics, but I didn't see this for the rotation. So you have a lot of very useful animations for rotation. We can go through some of them here, and then we can discuss that before going into your numericals. இந்த மாதிரி ப்ராப்ளம்ஸ் அடிக்கடி வரும். So some of you might have seen that these kind of things. So you are standing on a platform, rotating platform, and the moment of inertia will change according to the mass of the person. I can change the mass of the person. You see, if I increase the mass of the person, it is slowing down. If I reduce the mass of the person, it is speeding up, which makes sense, right? And not only that, the radius of the path, person's path. So that means I can move the person closer to the center and see what happens. So if I bring the person closer to the center, is it getting faster or slower? Anybody? This is one case and this is another case. I am putting it pretty much outside. In another cases, I am bringing it very close to the center. Which one is faster? Can you see my screen? Can you see my screen? Students, please respond. Yes, sir. Okay. What about others? யாருமே ரெஸ்பாண்டே பண்ண மாட்டேங்கிறீங்க. ப்ராப்ளம்ஸ் கொடுத்தா தான் ஒன்றும் வாய் திறக்க மாட்டேங்கிறீங்க. அட்லீஸ்ட் அனிமேஷன் காமிச்சாலாவது ஏதாவது வாய் திறப்பீங்கன்னு பார்த்தேன். அதுக்கும் வாய் திறக்க மாட்டேங்கிறீங்க. So can anyone tell me what's happening here? If you bring the person closer to the center, what will happen? Moment of inertia increase ஆகுமா decrease ஆகுமா? Moment of inertia increase ஆகுமா decrease ஆகுமா? தெரியாது சார். ஏதாவது ரெஸ்பாண்ட் பண்ணீங்கன்னா I can do something. Okay, I will keep waiting. The class முழுசா வெயிட் பண்றதுனாலும் I will wait. ஓகேவா? ஸோ யாராவது ஆன்சர் பண்ணீங்கன்னா நான் கிளாஸ் எடுக்கிறேன். அப்படி இல்லாட்டி நான் சும்மா
Inertia will decrease, sir.
அப்படி ஏன் அது ஃபர்ஸ்டே தெரியாதா? நீங்கள் யாராவது ரெஸ்பாண்ட் பண்ணீங்கன்னா இனிமேல் கிளாஸ் எடுப்பேன். இல்லாட்டி சார்கிட்ட சொல்லிட்டு இன்னும் பிளானிங் டு ஸ்டாப். நான் யாருமே ரெஸ்பாண்டே பண்ண மாட்டேங்கிறீங்க. ஓகே, தேங்க்யூ வெரி மச். சம்படி ரெஸ்பாண்டட். ஓகே, சம்படி ஹேஸ் த கட்ஸ் டு ஓப்பன் தேர் மவுத். ஸோ ஆஸ் யூ கம் க்ளோசர், ரைட், mr ஸ்கொயர்ட் வில் டிக்ரீஸ். ஏன்னா ஆர் குறையிறதுனால mr ஸ்கொயர்ட் வில் டிக்ரீஸ், விச் மீன்ஸ் மொமெண்ட் ஆஃப் இனர்ஷியா வில் டிக்ரீஸ். Same thing with the radius of the cylinder. If I decrease the radius of the cylinder, you see, the mass is concentrated or coming closer to the center, which means moment of inertia will decrease. Moment of inertia decrease ஆச்சு அப்படின்னா it will spin faster. அதே நான் வந்து moment of inertia just radius பெருசு பண்ணாக்க the mass is kind of spread out, which means moment of inertia will increase, which means the speed has decreased, omega will decrease. So I recommend you to not try these things. Okay, it's very, very useful animations. Rolling motion, I'm not sure how much you have studied, but I can show you some animations here, very useful animations. So you can run this. So you see, this is a spherical shell. Spherical shell, moment of inertia 2 by 3 mr squared. Okay, so if you don't remember, you can go back and check it in the handbook. Okay, as usual, it will get stuck here every time I open this. I don't know why that happens. So go to System of Particles chapter and start looking into moment of inertia. So moment of inertia, I told you have to be thorough with all these numbers, right? These formulas. So ml squared by 12. For ring, it will be mr squared. For solid cylinder or solid disc, it will be half mr squared. For hollow sphere, it will be 2 by 3 mr squared. For solid sphere, it will be 2 by 5 mr squared. So whenever it is solid, which means the mass is kind of spread out. Here, all the mass is in the rim, which means the moment of inertia will be higher, mr squared. இங்க பாத்தீங்கன்னா half mr squared, so it will be less. அதே மாதிரி hollow sphere பாத்தீங்கன்னா mass is concentrated in the outer surface, 2 by 3. இதே பாத்தீங்கன்னா solid sphereல mass is concentrated, mass is spread out everywhere. அப்போ 2 by 5 will be around 0.4, 2 by 3 will be 0.6. அப்போ this will be less, moment of inertia will be less. Okay, so this is what you should know. So rolling motion vachu, sometimes they ask you questions in Neet, so you should be thorough with that. JEE advanced la you have rolling motion. Okay. So coming back to this, you can see spherical shell, solid sphere, cylindrical shell, solid cylinder. And this is like a frictionless cube. So this is frictionless surface. You can change the angle, right? You can make it steeper or you can make it shallower. Then if I run it, so you see, this is sliding one is coming faster because no friction. And rolling அப்படினாலே கண்டிப்பா there should be some friction. அப்பதான் வந்து roll ஆகும், இல்லாட்டி slide ஆகும். So you can see the solid sphere is coming first. And then I think it will be spherical shell because 2 by 3 is 0.6. This is 0.5. Maybe the red one and the yellow one will be the first one and the yellow one, which is the cylinder, will be the second one because this is 0.5, this is 0.6. That's what I think. Let's run it and see. Yeah, so we can run it one more time. So you can see the red one is coming first here. Okay, you can skip this cube here. So green and yellow are very close. So let's run it one more time. So yeah, yellow one is the first, it's the second one, and the green one is the third one. So lower the moment of inertia, it will come faster, right? Because it will drive faster or roll faster. And of course, this is a separate one. This will be the first one. Okay, so as time permits, play around with it. You will learn a lot of useful stuff here. And I think we did some problems based on tau is equal to R cross F. So இதெல்லாம் similar to that. So we're applying certain force here, and then it causes a torque. So we can calculate the alpha using tau is equal to I alpha is equal to tau is equal to R into F. Right? So we did some problems based on this. Okay, so I will leave it to you. You can, play around with that. So whenever I ask a question, I expect somebody to respond. Okay, respond பண்ணல அப்படின்னா I'm going to stop there and inform KSF sir that students are not responding. So that's going to be my method hereafter. So if you want the class to progress, you have to respond then and there. At least you have to tell me, sir, I don't know. சும்மா உட்காந்துட்டு இருந்தா it just feels like I'm teaching for some empty wall, empty class, something. Okay. Okay, the last two classes, I think I did somewhere around 50 or something, 50, 51, 47. Maybe we can do some more. 45. I remember doing 46. Maybe we can try 47. So maybe we can start from 47. And then depending upon if you have any doubts, we can discuss that also. Okay. So generally rotation motion, students will find it a little bit difficult. That's why, I thought we can spend more time. Generally, I take only 2 classes per chapter. This one is slightly longer chapter, and then I'm sure many of you might find it a little bit difficult. But actually, if you know the simple formulas which is given in the handbook, I'm sure you can do it well. Okay, so that's the purpose of this class, to make sure that, to show you that it is all, easy problems in it. Find masses M1, M2. So let's try this. Find masses M1 and M2 are placed at the opposite ends of a rigid rod of length L and negligible mass. The rod is to be set rotating about an axis perpendicular to it. Okay. The position of point P on this rod through which the axis should pass, so that the work required to set the rod rotating with the angular velocity omega naught is minimum. So they are saying omega naught should be minimum, which means the moment of inertia should be maximum. I should be maximum. Okay, because angular momentum is kind of So how to say this? Suppose in a linear world, if I say the velocity should be minimum, then the mass should be maximum. When the mass is more, velocity will decrease. Same concept here. Instead of mass, it will be moment of inertia. Instead of velocity, it will be omega. So this is given as x and this is given as L minus x. So the moment of inertia I will be,
Sir, are they inversely proportional to each other?
yeah, so I, when this is minimum, this will be maximum, right? So I, moment of inertia will be m1 x square for this one, this mass. And then for this mass, it will be L minus x, so plus m2 L minus x. So to make this maximum, right, I should differentiate this di by dx. Maths, I think you must have studied maxima, minima. So maxima, minima point line agum, you will get the slope to be 0 because dy by dx. So take it down properly. At maxima, minima, dy by dx will become 0. Maths la படிச்சிருக்கணும் ஓகேவா படிக்கல அப்படின்னா 12th வரும்னு நினைக்கிறேன். So I'm not sure when it is coming. So that means the slope is this line. Okay, so at the maximum point and minimum point, it will become flat. Flat means it is 0. So that means I have to calculate the di by dx. So m1 is a constant. X is what is changing. So that means they're asking you to find where should I place this point P. The position of point P on this rod. So that means it will be 2x. Plus, actually, after doing 2x, I have to differentiate x also with respect to x, which means dx by dx, I will get 1. That's why I'm not writing it here. Because sometimes if you are differentiating with respect to time, then after doing this, you have to say dx by dt, you have to write it. So if I differentiate this 2 times L minus x, and 2 minus 1, it will become 1. And then by chain rule, I have to differentiate whatever is inside the bracket. L is a constant, so if I differentiate that, I will get 0. Minus x, if I differentiate it, I will get 1. dx by dx will get 1. So that means at maxima, minima, di by d, this thing should be equal to 0. That means this should be equated to 0. So m1 2x, and the minus when it goes on the other side, it will become plus. So m2 2 times L minus x. So simplify this, we'll get the answer. This minus, when it comes on this side, it will become m1 plus m2 into 2x. I want x. Remember, they are asking you to find the position. So that means x is what is required. So 2 will cancel. So x will be m2l divided by m1 plus m2. So m2l, m1 plus m2. Okay, so the concept here is moment of inertia should be maximum for the velocity to be minimum. இப்போதான் அந்த simulation I showed you, that simulation. So if the moment of inertia is minimum, the omega will be maximum, right? If we bring it to the closer to the center, the person standing on a platform, you will see that it is kind of spinning faster. That's why I told you, studying the simulations are very, very important. So you have to understand the simulations. Then you can connect your problem solving knowledge with the simulation. Anybody having any doubts? Can I go to the next one?
No, yes, sir.
Okay, very good. I'm going very, very slow because this is slightly difficult chapter. That's why I'm going slow. Otherwise, I would go a little bit faster. So you have to, let me know. If you find it very slow, we can go a little bit faster. An automobile moves on a road with a speed of 54 km per hour. The radius of its wheel is 0.45. And the moment of inertia of the wheel about its axis of rotation is moment of inertia I is equal to 3 kg meter square, mr square. If the vehicle is brought to rest in 15 seconds, the magnitude of the average torque transmitted by its brakes to the wheel is. இது பார்த்தீங்க அப்படின்னா நிறைய பேர் வந்து என்ன சார் ரொம்ப கன்ஃபியூசிங்காக கேட்டிருக்காங்க அப்படின்னு திங்க் பண்ணுவீங்க. Actually, it's very simple, right? So only if you practice these kind of problems, you will understand that it's a very, very simple problem. Okay. So magnitude of the average torque. So that means they are asking about tau. So tau is equal to I alpha. Okay, so they're asking you to find this one. I is given. If I find alpha, then I can find torque. Okay, how do I find alpha? The final velocity is brought to rest, which means final velocity is omega final is 0. In time 15 seconds. That means use your equations of motion, right? Speed they said 54 km per hour, which means I can tell you what is the omega initial. So 36 km per hour abdina, you should know by this time it is 10 meter per second, correct? 72 km per hour abdina 20 meter per second தெரிஞ்சிருக்கணும். இது உட்காந்து எக்ஸாமில் கால்குலேட் பண்ணிட்டு இருக்கக்கூடாது. அப்போ இது ரெண்டுக்கும் நடுவில் 54 km per hour அப்படின்னா இது வந்து 15 meter per secondன்ட்டு உங்களுக்கு இமீடியட்டாக தெரியணும். ஓகேவா? ஸோ இதெல்லாம் ஸ்டாண்டர்ட் நம்பர்ஸ், எவ்ரி டைம் உட்காந்து கால்குலேட் பண்ணிட்டு இருக்கக்கூடாது. ஓகேவா? ஸோ 36னா 10 meter per second. If you have doubt, you can calculate it and check it. Appo I know this one, right? I know V is equal to R omega. Appo omega initial இது வந்து இதோட velocity. For V is equal to R omega வச்சு I can calculate the omega I. So V is 15, R is 0.45, omega initial is what I want. So omega initial is equal to, this will come on the side, so it will become 15 into 100, sorry, multiply by 100 divided by 45. So I can cancel it as 3 times, so 100 divided by 3 radians per second. So that means I know omega initial. So I know V is equal to U plus AT, which means I can write it as omega final is equal to omega initial plus alpha into T. Omega final is 0, omega initial is 100 by 3, alpha is what I want. I know that I am trying to stop the vehicle, which means alpha will be negative. So T is 15 seconds. So alpha is equal to minus 100 by 3 divided by 15. So that's my alpha, radians per second square. So we found alpha, which means tau can be easily found. So tau is equal to I alpha. I is given as 3. You can ignore the minus because they said stopping torque. So 3 into 15. So 100 divided by 15. How much is that? Any answers?
20 by 3.
20 by 3. Newton meter, right? Torque. So 20 by 3, do you have it? 6.66, right?
Yes, sir. Correct, sir.
Newton meter.
6.6.
Yeah. Kg meter per second square into meter. So that means it becomes kg meter square second square. So yeah, 9 units are also correct. Okay, very simple problem. படிச்சு பார்த்து ஏதோ காம்ப்ளிகேட்டட் நினைச்சு you should not skip it. Okay. Can I go on to the next one?
Yes, sir.
Yes, sir.
Okay, very good. A rod of weight W is supported by two parallel knife edges A and B and is in equilibrium with in a horizontal position. So this is my rod. The knives are at a distance of D from each other. Center of mass of the rod is at a distance of X from A. So that means knife edges means something like, supporting block like this. So maybe it is not perfectly symmetrical. So I'm going to call this as A, this is B. It's in equilibrium in a horizontal position. The knives are at a distance of D. So that means this is at a distance of D from each other. The center of mass of the rod is at a distance of X from A. So that means, let's say this is my center of mass of the rod. So this is at a distance of X. So center of mass means weight will be acting from the center of mass, or that's what we would assume. So that's one point through which the weight will be acting. Normal reaction on A. So very simple, nalla gavaninga. If I say that there is some rod kept over here or weight வைக்கணும் அப்படின்னா இங்க இருந்து there will be some normal reaction. So that means there will be a normal reaction here. So we can call it as NA. அதே மாதிரி there will be a normal reaction here, NB. Okay. Is there any other forces involved? So weight is acting this way. That means normal reaction will be acting upwards. Okay. So that means you should know that only these three forces are acting, and then I can take moment of inertia. Actually, X is up to this point. Okay. So I can take moments about A or B. So the first step I would say is sigma F is equal to MA. That's the most important formula in mechanics. But here it's not moving, which means acceleration is 0. So that means NA is upwards, NB is upwards, W is downwards, which means I should put minus. And since it's not moving, I'll put a 0. You could have directly written it as NA plus NB is equal to W எழுதலாம். But when you are studying the concepts, I would say start from the basics. So that when you have pulley problems, you can use the same. Mechanics, more than 90% of the time, again and again, you will be using this formula, particularly forces chapter. And then similarly, you must have studied, this is true only in equilibrium. So similarly, you must have studied sigma of moments about any point, right? I can take moments about A, moments about B, or even I can take moments about center of mass. But here I am going to take about B. Why 0? Because it is in equilibrium. So equilibrium torque from this torque and this torque will cancel each other. Suppose it's not turning nartham. That's the meaning of equilibrium. So that means NA into D. So I'm taking about point B. So that means NA into D. So force into distance. And this is clockwise. So generally anti-clockwise we take negative, clockwise we take positive. You can change the convention, but you should follow the same convention throughout the problem. You cannot keep changing the number. Generally நம்ம ப்ரொட்ராக்டரில் நீங்கள் ஆங்கிள் எடுக்கும்போது இப்படி எடுத்தாக்கா பாசிட்டிவ்னு எடுப்பீங்க, right? When you go this way, you will take it as negative. So I am following the same convention. So clockwise abdina, I am taking it as minus. If you see W above this point, this distance is D minus X. In the distance. That means W is turning both this way. So that means plus W to D minus X. I want normal reaction at A. That means Na will go on the other side. You can do the math yourself. So Na will become Wd minus X divided by D. So that's your correct answer. Okay, suppose if they had asked you to find Nb, I would have taken the moment of inertia about A. Why? Because then Na will cancel. In this case, Nb is cancelling out. So that means I will get only Na. Everyone following that? NB, in the moment of inertia about B எடுத்தோம் அப்படின்னாக்கா NB வந்து cancel ஆயிடும். ஏன்னா NB into distance from this point is 0. அப்போ 0 into NB will become 0. So that's why it's a trick that உங்களுக்கு NA கேட்டிருந்தா take the moment about B. NB கேட்டிருந்தா take the moment about A.
Yes, sir.
Okay. If you want, I can show you, I can calculate the moments about A and find out NB. நம்ம ட்ரை பண்ணி பார்க்கலாம் and see whether it comes out this இந்த இது வந்து கரெக்டாக satisfy ஆகுதான்னு செக் பண்ணி பார்க்கலாம். Again, if you have time in your exam, you can do all these things. If you don't have time, you should not do these things. Only for studying, when you are studying in home, you can do these things. So about this point, so NB anti-clockwise, so positive, so NB into D. And W is clockwise, so W into X. Why minus? Because now it is clockwise. About this point, this will produce a clockwise moment. About this point, this will produce a anti-clockwise moment. So that means if I want NB, I will get Wx divided by d. So if I add this and this, Na plus Nb, W by d is common. So what is inside is d minus x plus x. If x cancel out, d cancel out, I get W. That means verified. Okay, again, this is not required. You can stop here itself, right? This is only to show you that how you can double check your answers. When you do these kind of things, your confidence level will improve. Okay. A mass m moves in a circle on a smooth horizontal plane with a velocity v naught at a radius r naught. That means it is spinning at a radius of r naught. Okay, I am seeing it from the top view. Mass is m with the velocity v naught. The mass is attached to a string which passes through a smooth hole in the plane as shown. So that means this is kept on a table or a board, and I can pull the string through this hole here. Okay, so that means when you pull it, what will happen? This will come closer. So the tension in the string is increased gradually, and finally m moves in a circle of radius r naught by 2. So that means you are pulling the string so that this mass is pulled closer to the center. Suppose this radius is becoming r naught by 2. So the final value of the kinetic energy is, so that means when you bring it closer to the center, what will happen? The moment of inertia will decrease. Moment of inertia decrease achapdinaka, omega will increase because angular momentum is constant, right? So that means you should know that momentum before is equal to momentum after. Only thing, we are not talking about momentum, we are talking about angular momentum, okay, because it is rotational motion. So angular momentum before is equal to angular momentum after. So I initial, omega initial is equal to I final, omega final. Okay, so why would I do that? Because omega final terinjada, I can calculate the kinetic energy. They didn't say properly. To confuse you, they are just given final value of the kinetic energy. But are we talking about linear kinetic energy or rotational kinetic energy here?
Rotational.
Rotational, very good. So that means kinetic energy rotational is half mv squared and varedada. Mass badala enna ponnum? Moment of
inertia half
velocity badala enna ponnum?
Omega
I
square.
omega square.
Omega square. So that means the final value of kinetic energy is this one. That means only if I find the omega f, I can substitute it over here. So that means that's why I'm starting from the angular momentum. So very often you will get questions connecting angular momentum or conservation of angular momentum with kinetic energy rotational. Yeah. So I would say it's all very straightforward questions. Okay. So I initial அப்படின்னா m r squared. Omega initial is, they didn't give it directly, but I know that omega v is equal to r omega. அப்போ omega is equal to v by r. அப்போ v naught by r naught. I final is m r squared, which is r naught by 2 the whole square. So be careful, put the brackets correctly. Brackets போட்டு ப்ராக்டிஸ் பண்ணிட்டீங்க அப்படின்னா மிஸ்டேக்கே பண்ண மாட்டீங்க. m r squared, but r is r naught by 2 in the final situation. Omega final is what I want. So r naught cancels, m cancels. Actually, I could have cancelled the r naught square here. So 2 will come here. So 2 times v naught by r naught is your omega f. Actually, this is 2 square, which means it is 4. So it will be 4 times. Okay. So I final will be m r naught by 2 the whole square. Omega final is this one. So 4 times v naught by r naught the whole square. M will be there. R naught square will cancel. There is R naught squared here. There will be a 4 squared here. And V naught squared here. So 4 into 4 V naught squared divided by 2 into 2 naught, 2 into 2. 2 squared here. I hope I have not missed anything else.
Option B.
So 2 mv naught square, yeah. Okay, very good. Everyone following this? You see, if you know the concepts, it's very, very easy. Okay. Angular momentum conservation and kinetic energy rotation. As I told you, we should be thorough with this table. In the table thorough, you can do all the linear to rotational. It's documented here properly, so you have to make use of this properly. So kinetic energy rotation. Where did it go? Kinetic energy, yeah. So you see kinetic energy half mv squared, half I omega square. The basics, if you study it properly, I'm sure you can do it very well. Okay. Actually, I don't have enough space. So. Close the windows, there is some noise here. Okay. So uniform circular disc of radius 50 centimeter. So uniform disc, it's not a ring. So uniform disc of radius 50 centimeter. At rest is free to rest. So that means initial velocity is omega is 0. Free to turn about an axis which is perpendicular to its plane, passes through its center. So that means they are talking about a disc like this, like the rotating platform which we saw in the animation. It is subjected to a torque which produces a constant angular acceleration of 2 radians per second square. So that means constant angular acceleration is 2 radians per second square. 50 centimeter radius, okay. Omega initial is 0. Its net acceleration in meter per second square at the end of 2 seconds is approximately. Okay, this is a very important type of problem, so please listen carefully. So, ஒரு கான்ஸ்டன்ட் ஸ்பீடில் ரொட்டேட் ஆகிட்டு அப்படின்னா இட்ஸ் யூனிஃபார்ம் சர்க்குலர் மோஷன், which means you will have only centripetal acceleration. So centripetal acceleration is equal to mv squared by r, which can also be written as mr omega square. So இது கண்டிப்பா எல்லாருமே படிச்சிருப்பீங்க, ஓகேவா? So which is acting towards the center. Okay, so when you are here, it will be acting towards the center. When you are here, it's acting towards the center. So everywhere it is acting towards the center. Ana, if it is non-uniform circular motion, right? Apna anartham, speed is increasing. It's not constant speed. So non-uniform circular motion appadina, in addition to that acceleration, you will have one more acceleration. ஏன்னா இந்த பக்கம் ஆக்சிலரேஷன் இருந்தால் தான் ஸ்பீட் இன்க்ரீஸ் ஆகும், இல்லாட்டி இன்க்ரீஸ் ஆகாது, அதே ஸ்பீடில் தான் போயிட்டு இருக்கும். ஸோ தட் மீன்ஸ் ஒன் ஆக்சிலரேஷன் இஸ் ஆக்டிங் டுவர்ட்ஸ் த சென்டர், ஏசி சென்ட்ரிபிட்டல் ஆக்சிலரேஷன். Another acceleration is called tangential acceleration, AT. அப்போ total acceleration கேட்குறாங்க அப்படின்னா, when they ask you the total or the net acceleration, so AT இங்க இருக்கும், centripetal will be towards the center, which means it will be like this, which means this will always be 90 degree. ஏன்னா எங்கே போனாலும் இது வந்து tangential தான் இருக்கும். So take it down properly. So this is what is your A resultant. Okay. That means if you know these two things, I can easily find this using the Pythagoras. So coming back to this, they are asking you to find the net acceleration. Okay. இப்போ ஸ்பீடு வந்து இன்க்ரீஸ் ஆகிட்டே இருக்கு. ஸோ வி நீட் டு ஃபைண்ட் த ஏடி அண்ட் ஏசி. AC will be mr omega squared. So moment of inertia tau is equal to I alpha. So tau is equal to I alpha. Can I use tau is equal to I alpha? Omega initial, omega the end of 2 seconds. So that means I can find omega f. So omega final, I want it. Omega initial is 0. alpha is 2, time is 2, which means omega final is 4 radians per second square, sorry, radians per second. So omega final is known, which means I can find this one, Mars omega squared. But I want centripetal acceleration of the disk. So I omega. I omega will give me angular momentum. Angular momentum will not help. Let me check. So from this I can find centripetal acceleration, which is r omega square, right? So this is my acceleration. So r is given as 50 centimeters. So 50 centimeter means 4 squared. So 16 by 2, so it will be 8 meter per second square. And then how do I find AT? So just now, just like V is equal to R alpha, right? So we have a separate formula for tangential acceleration. So if you have not seen tangential acceleration earlier, you can go to circular motion chapter. Circular motion, yeah. So here I have given you uniform circular motion, and then you have non-uniform circular motion. So in uniform circular motion, whatever we use all the time, right? Mr square, Mr omega squared, mv squared by r is there. In tangential acceleration, you can go through this basics, right? So we have derived AT as r alpha. This is similar to V is equal to r omega. In the A is equal to r into alpha. Okay, so that means if I know this formula, I can easily calculate AT. So AT is equal to R into alpha. R is radius. So radius is again 1 by 2. Alpha is, I think it's 2. So it will become 1. Again, exam you don't have to worry about the units, right? So you can quickly do it. Just for your understanding, I'm writing all the units properly. So that means A resultant is equal to square root of AC squared plus AT square. AC is 8 square plus 1 square. So 64 plus 1, it will be root of 65. It means something close to 8 point something. So 8 point something. Actually, it should be greater than 8 point something. Okay. Everyone following this? So this is uniform circular motion. This is non-uniform circular motion. Okay. So that means you have to include both the components. Okay, very simple if you know these two formulas. Okay, can I move on? Okay, I'm going to take it as yes. Okay, this also, I think we did this kind of problem in the last class. Maybe if you want, we can do some. rope is wound around a hollow cylinder. So, near the wells, you must have seen these kind of things, like, ropes. The well will be like this. At least in movies, you must have seen if you are not been to a village or something. So they will have something, wound across this. Then this entire thing will be spinning, right? On one end, you will have the bucket, and the other end, you will be pulling it with your hands from here, right? Hollow cylinder of mass 3 kg and radius 40 centimeter. What is the angular acceleration of the cylinder if the rope is pulled with the force of 30 Newton? So I think I showed you this in the animation. So you can go back and check the animation. So when you are pulling it with certain force here, this is 30 Newton. Okay. So radius is 40 centimeters. So I told you many times, it's a very direct formula. Tau is equal to I alpha. Another formula is tau is equal to force into perpendicular distance. Now you can equate this. I alpha is equal to F into D. So I think it will work. What is the angular acceleration? So alpha has to be found. Hollow cylinder, it's something like a ring, which means it will be mr squared. I is equal to mr squared. So mr squared அப்படின்னா 3 into 40 centimeters, so 40 divided by 100 the whole square. Alpha is what is asked, 30 Newton. Distance is radius. Radius is 40 centimeter. So I think alpha will be coming around 10 into this thing. So this 0 and this 0 we can see. So 100 by 4, so it will be 25. Yeah, so very simple problem. Okay, if you know this, sometimes, instead of giving hollow cylinder, they will give you a solid cylinder. Solid cylinder means it will be mr squared by 2. So you should be thorough with all the shapes given in your handbook. Okay, I think you have some 4 or 5 shapes given in the handbook. So you should be thorough with all these things. So I will show you where it is. Yeah, after this. So we should know for this rod, and then for hollow cylinder, hollow sphere, solid sphere. Okay, so these are all the basic shapes. Very often they will ask you. So you should know these things. What is this K? Don't worry about it. Radius of gyration. Okay, so it's coming later. So when you're studying rolling motion, you should know this. But for now, I would say study only the boxed ones. Okay, whichever is in the box, you should remember this. And using the parallel axis theorem and perpendicular axis theorem, you should be able to calculate the other moment of inertias. Okay, so very often we have been using this formula, so be thorough with this. I think this is very similar like what we did, so I'm going to skip that. Maybe we can do 54. Find the torque about the origin when a force 3J acts on a particle whose position vector is 2K. So torque is nothing but R cross F. Okay. If you don't know that, you should be thorough with the handbook formulas given here. Okay. So tau is equal to R cross F. You should know this, linear to rotational. So R is given, F is given, simply do the math, right? So you should do the cross product. So determinant I have to find. So this is R is 2K. So that means this will be 2 here and then zeros over here. And for the force it will be 3J, which means 3 over here, zeros over here. So find out the determinant. Okay. Or actually you could have done it directly like this, J cross K. Okay, I think that will be easier. If you don't know that, you can do it like this method also. But you can do 2K cross 3J. That means it will be 6I think. I is here, J is here, K is here. So use your right hand thumb rule. So if I put K cross J, I will get minus I. Everyone following that? Put your right hand thumb rule. So K cross J, if you fold your fingers, your thumb will be pointing this way. Everyone doing that? Anybody having any doubts? Purida Purilia
No, sir.
So that means you will get minus 6I. Okay. If you have doubt, you can do it in this method also. So I here 0 minus 6. Then J it will become 0, K it will become 0. Right? J, yeah. That means I will get minus 6I here also. So as I always say, if you know more than one method, you will feel confident. Moment of inertia, rotational kinetic energy, and power. Okay. A ring of mass m and radius r rotates about an axis passing through its center and perpendicular to its plane with angular velocity omega. Its kinetic energy is, so that means this is the ring, this is the moment of axis of rotation. So the ring means I can show it something like this. Okay. Perpendicular to its plane, angular velocity omega. So its kinetic energy means again it's rotational kinetic energy, right? We are not talking about linear. Half I omega square. Half I moment of inertia for the ring will be mr squared. Omega will be simply omega square. So half mr squared omega squared, yeah. So that will be my correct answer. Okay, very simple, nothing very difficult. I think this is also very easy only, nothing very difficult. A flywheel rotating about a fixed axis has a kinetic energy given when its angular speed is omega is given. Moment of inertia of the wheel above the axis of rotation is, so kinetic energy rotation is equal to half I omega square. So substitute the numbers, we'll get the answer. So kinetic energy is given as P60 joule. Moment of inertia is what is asked. Omega is 30 radians per second. So 30 square. So simplify this and get the answer. So 4 2s are 8, 8 divided by 10.8. Okay. I think this is very similar, so I'm going to skip 57. 58 we can try. Whenever there is some algebraic questions, you folks get frightened a little bit. So moment of inertia of a uniform circular disk, okay, of diameter L. Its moment of inertia about an axis perpendicular to its plane and passing through a point on its rim will be. So they are saying that this is a disk. So this is our usual moment of inertia about this axis will be, I will be mr squared by 2. For ring it will be mr squared, for disk it will be mr squared by 2 because mass is spread out, which means moment of inertia will decrease. Now what they are asking is perpendicular to its plane and passing through a point on its rim. So that means anywhere on the rim. So that means somewhere here. So they are asking you to find the moment of inertia about this point. So if you want, you can call this as IA. So IA is equal to, this is called IG. What is IG? Anybody? Moment of inertia about? What does G stand for? So it's about the center of mass, right? So moment of inertia about the center of mass plus mr squared. That's the formula. Which theorem is this? Anybody? Parallel axis theorem or perpendicular axis theorem?
Parallel axis theorem, sir.
Okay, very good. Parallel axis theorem, you folks have studied, right? Otherwise, you have to be thorough with parallel axis and perpendicular axis, right? So this is your ICM plus MD square, or sometimes some books will use IG. G stands for center of gravity or center of mass. Okay, so that means very often we'll be using perpendicular axis theorem and parallel axis theorem. So you should know this, especially for all your Neet and JE questions. Definitely you will get this kind of problems. That's all. So if you know this, it's very easy. So that means it's moment of inertia about an axis and passing through a point on its rim. So that means it will be this one, mr squared by 2. Mr squared by 2 plus mr squared. So that means it will be 3 by 2 mr squared. So I think something is missing in the question. What is I? What is? Moment of inertia of a uniform circular disk about a diameter. Oh, okay. So I think something is missing here in the question. So maybe what they meant was about a diameter L means, I think this is not this one. So that means, so about a diameter means it's along this point, which means I think it will be like mr squared by 4. Okay, if you have doubt, you can always go back to and check it in the handbook. So for disk, both the diameter means it will be mr squared by 4, this one. So this one, Ix and Iy, mr squared by 4. Okay. And that is making use of the perpendicular axis theorem. So if I add this mr squared by 4 plus mr squared by 4, I will get mr squared by 2 in the perpendicular axis theorem. So that means this is given as I. I think something is missing in the question. Maybe they meant this is your I. That means this should be taken as 2I. And if this is mr squared by 4, this is also mr squared by 4. According to moment of perpendicular axis theorem, if I add this and this, I should get the moment about this axis perpendicular to the paper, which means it will become mr squared by 2. So that means it will be 2 times I, because I'm adding I and I. So this is 2I. According to this formula, I can use 2I plus the distance, which is mr squared, so if this is I, mr squared is 4I, so that means this will become 2I plus 4I, which means it will become 6I. So 6I is the correct answer. Okay, so the question, I think something is missing in the question. So go through this. If you have any doubts, I can give you a couple of minutes. Okay, no doubts? Okay. Okay, my suggestion is maybe we can stop here. Let's see if we have done at least 10 problems here. Yeah, I think we must have done at least 10 problems. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, around 10 or 11 we have done. Okay, very good. Okay, so my suggestion is continue with this chapter. I think you folks are having some holidays, so make use of the holidays, and let us make sure that your 11th portions are thorough. Okay, at least this is an opportunity for you to now make your 11th portions thorough. And maybe I'm thinking we will do one more class in this chapter, and then we'll go to some other chapter. Okay, whichever chapter you feel you need some help, we can do that. Do you have any chapter like that? Maybe I'm thinking loss of motion could be a good chapter. நிறைய problem diagram based questions நிறைய வரும். So maybe we can do that. Is that okay, everyone?
Yes, sir.
Okay, very good. So my
Yes,
suggestion
sir.
is,
We can discuss further.
hmm? What did you say? என்ன சொன்னீங்கன்னு கேட்கல. Okay. Anyhow, my suggestion is you have some holidays, I think, so make use of the time. The remaining problems, I think you have around up to 90 something. So another 30 problems or something is there. So please try this and come. We can solve another 10, 15 problems in the next class. And then we can continue with the next chapter. Okay. My intention is, இப்போ இந்த ஹாலிடேஸில் whichever chapter you're not thorough, if you do that in right now, probably you will have time to work out the problems. ஓகேவா? அதுக்கப்புறம் maybe whenever Keshav sir says, we can get started with the 12th portions, because I think that you should do more of 12th portions also, because you have to do, you have to go along with your school work. Okay, so in the holidays மட்டும் maybe we can complete this 11th portions. Any feedback, anything? Everyone following everything? No issues?
No issues, sir.
Okay, very good. What about you, Samyukta?
Yes, sir. It's fine.
Okay. What about others? Sujit, Sindhamil Chelvan? Okay. Okay, I'll stop here. Thank you all. Bye.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.